Average atomic mass. This is the number you will find on the periodic table. It is usually right below the symbol on the periodic table. Our definition of average atomic mass is it is the weighted average, which is slightly different than just a regular average. A weighted average mass of all the isotopes of that element. So this is math. We are going to do some calculations. Before we get super duper concerned with the calculations, we're going to go down here and think about what an isotope is. We learned this a little while back. An isotope is, or they are atoms of the same element. And if they're the same element, that means they have the same number of protons. And a different number of neutrons. Remember, the neutrons are those particles that have no charge, so it does not change the element. If you add a few more neutrons or if you don't have as many, you're not changing the element. You just have a different isotope of that element. And we write isotopes a couple different ways. One way, I'm going to use carbon as an example here. One way is to think of the symbol in a box, and we would put the mass number up above and the atomic number down below. So the number that I just wrote up there, number 14, is the mass number. And one isotope of carbon has a mass number of 14. Remember, mass number is protons plus neutrons. So that goes up above. And then the number that goes down below is the atomic number. The atomic number is the number of protons. Only protons. So it's, we don't usually write or draw in the boxes. So it usually looks a lot more like that. So that would be one isotope. A second isotope of carbon is carbon-12. So it would be written like this. Again, the atomic number is going to be the same for each because it's carbon. And all carbon has 6 protons. However, the mass number will change from one isotope to the next because each isotope has a different amount of neutrons. This carbon has 6 neutrons, and this carbon has 8 neutrons. A second way that we can write different isotopes is by writing out the name and then we use a dash and we put the mass number at the end. So we use the name, the full name, and then the mass number goes afterwards. So we could do carbon-14, or we could write it out as carbon-12. Okay, so that's a quick review of isotopes and an explanation All right, so when we talk calculating our average atomic mass, we have to look at how many different isotopes exist. I have 3 here, but there could be more. That's my dot 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 right there. That means we're going to continue to do that for as many isotopes as we have. Or if there's only 2 isotopes, then we would only have 2 sets of parentheses. So when we talk our equation, it's pretty general. We take the mass of isotope 1 times the abundance of isotope 1 plus the mass of isotope 2 times the abundance of isotope 2 plus the mass of isotope 3 times the abundance of isotope 3, and on and on and on. Okay, so when we talk mass, we are talking mass number. We want the total number of protons plus neutrons. Protons plus neutrons. That's what we mean by the mass of that isotope, which again kind of gave you a little reminder down here. We're going to do an example right there also. Abundance. Abundance is the one that seems to be a little bit trickier. Sometimes the abundance will be given as a percentage, which again is anything over 100, right? A percent. 50% could also be written as 50 over 100 if we wanted to write it as a fraction, because that's another possibility. We could be given information saying that 15 out of every 20 atoms is that specific mass. So then we could write our own fraction, which we could just reduce it, or we could convert it into a percent if we wanted to. It can kind of take on many forms. So sometimes it'll be a percent. Sometimes we can just use it in the fraction form. But the abundance is really going to be how common that isotope is. Okay, I have 3 isotopes drawn, and this element, so these are the nuclei of this element. This happens to be, if my dark pink ones are protons, I have 8 protons, 8 neutrons. That means this is an isotope of oxygen, because oxygen is the element that has 8 protons. So we have, actually let's write it like this. We have oxygen, 8 is my atomic number, so it's going to go on the bottom. This mass is 16. Over here we have oxygen 17. Again, 9 plus 8. And then the third isotope is oxygen 20. So 3 isotopes for oxygen. Again, I'm giving their mass number. And the other part that I need in order to calculate average atomic mass is the abundance, or how common this isotope is. So we know that oxygen 16 is by far the most common isotope of oxygen. So 95% of atoms, oxygen atoms, are oxygen 16. About 3% are oxygen 17, which means about 2% are oxygen 20. To calculate the average atomic mass, we want to use the formula that I have up there, but always remember weighted average. So I know I have 3 different masses, but before I do any calculations, because 95% of my atoms are oxygen 16, my answer had better be very, very, very close to 16. I know it will not be less than 16 because my other masses are above 16. So these are really good problems to make sure your answer is reasonable. We don't want it less than the smallest number and definitely not bigger than the biggest number. It's got to be someplace in the middle, and it's going to be closest to the isotope that is the most common. Okay, I have some examples that are already written out down here, so we're going to kind of jump down there and do them. This is my block from the periodic table. Oxygen is our big giant symbol, O in the middle. The atomic number is usually in the upper corner, and this is on the periodic table. Okay, so it will vary depending on what your periodic table looks like. So this is just a little square from the periodic table. The atomic number might be in the very center, or it could be, I believe, on the periodic table in my classroom. I think it's in the upper right-hand corner. But this is the part that I want to highlight right now anyway, this is the mass, the average atomic mass. Usually it's given to several decimal places because there's a lot of information that's known about the mass of these elements now. The unit that these are measured in are called the atomic mass units. Not very fancy. We abbreviate it as AMU, the atomic mass units. In our atomic mass unit scale, a proton has a mass of 1. A neutron has a mass of 1. And an electron has a mass of 0. This is all defined based on a carbon-12 atom. A carbon-12 atom is the standard, and it's said that a carbon-12 atom has a mass of 12 AMU. So that means a proton is 1/12 of 12, which is 1, and a neutron is 1/12 of 12, which is 1. So carbon-12 is kind of the standard for our atomic mass units. It's one of the very, very most common atoms, so that's why that's used there. Anyway, so 15.99 is the average atomic mass of oxygen, and that number is in atomic mass units. So when we work problems calculating average atomic mass, we are going to label them as AMU. All right, let's work through these 2 examples. What is the average atomic mass of chlorine if it exists as 24% chlorine 35, 60% chlorine 36, and 16% chlorine 37? So I have 3 isotopes, and I'm going to turn my percent into a decimal and multiply that times its mass. So isotope 1 is right here. 24% is chlorine 35. Isotope number 2 is right here. So 60% is 0.6 times 36. And then third isotope, 0.16 times 37. Okay, I have it written out. going to grab my calculator, and just as we have parentheses written on the paper, I'm going to use those parentheses when I enter it in my calculator. And I get 35.92 AMU, which is, if you check that on the periodic table, it is a little bit higher than you'd find on the periodic table, but that's what happens when I make up my own problems. Anyway, it is reasonable based on this information because my smallest mass was 35, so it's greater than 35. My largest mass is 37, so it's less than 37. My most common mass, the most abundant, is the 36, and it is the closest to that 36 because 35.9 is very close to 36. Okay, next example. We have our information given to us in a slightly different way. So out of 200 magnesium atoms, 140 are magnesium 24 and 60 are magnesium 25. What is the average atomic mass? I need to write this as a fraction. So 140 out of 200 are magnesium 24. And my second isotope, I have 60 atoms out of 200 are magnesium 25. So I only need two sets of parentheses here because I only have two isotopes. I can enter that straight into my calculator, or you can convert your fractions to a decimal first. It's totally up to you. It is not going to change your answer at all. 0.7 times 24 plus 0.3 times 25. Okay, even before I hit the equals, I'm going to make a little prediction and say that my answer is going to be closer to 24 because that is the one that's the most abundant. So I'm going to predict that my answer is going to be closer to 24. And it is 24.3. AMU. Okay, there are two examples. One thing to note with your percents, if you forget to turn them into decimals, so if you just go with 24, if you go with 60, and if you go with 16, that's fine. Your number that you get is going to be big. 24 times 35 plus 60 times 36 plus 16 times 37. Right? 3,592. Hopefully, if you get that answer, it like sends off like red flags and you realize that that is not realistic. It's fine. You can then divide by 100. And again, that gives us the same answer. So just keep that in mind. Always, always, always check to make sure your answers are reasonable. So that is average atomic mass.